B plus trees are used in storing data for efficient retrieval in a block-oriented context, for example in file systems. If we take for example binary search tree, it always has at most 2 children, while B plus tree, here you can see the example, it can have many children nodes, not only 4 but also hundreds and thousands. And in B plus trees we use a notion of degrees. Degree is used, it has its purpose in the B plus trees. We denote it with a letter D, and it determines the number of pointers and number of keys. So at each node we have D number of pointers, not more, and we have D minus 1 number of keys. Here in the example you can see that the degree is equal to 4, and we have 3 keys, D minus 1 keys, and 4 pointers, D pointers. And there are some properties of B plus tree. First of all, all the information are stored in the leaf nodes. So if we're searching for 4, or if we're searching for 5, we should look for it in the leaves, in the child nodes, not in the internal nodes nor in the root. Okay, and the second property is that root node has minimum of 2 children, otherwise it cannot be considered as a B plus tree. So let's see. So this is our root, and it has left child and right child. So the property is hold, therefore it is a B plus tree. And the third property says that internal, so we call this node a root, and the intermediate roots we call them internal nodes or hash nodes or split nodes. Either way is correct. So these internal nodes, they have minimum of floor D divided by 2 children. So if our degree is equal to 4, then the minimum number of nodes the internal node should have is 2, and maximum they can have 4 pointers, so D number of children. Okay, and the fourth property is that leaves should have floor D divided by 2 keys minimum. It means that if degree is 4, it should have 4 divided by 2 keys. All the leaves should have minimum of 2 keys. So let's see. The first leaf has 2 keys. Second also has 2 keys. Third also has 2 keys, and the fourth leaf has 3 keys. But it's okay since the minimum is 2. And the fifth rule says that all leaves should be at the same distance from the root. So if we count, then we can see that actually all the leaves appear on the same level. So that means they are at the same distance from the root. And in this B plus trees, the keys of the left node will always strictly be less than the root node, but the right note can be equal to root note and bigger or bigger. So here, for example, 1 and 4 are both less than 9. However, in the right child, we can see 9 one more time, and this actually applies to the rule that it can be equal or greater than the root note. Okay, in the next videos we will see some examples of insertion and deletion in plus trees.